Welcome to episode 3 of What's in the Box, where we sit down and cover FactoryStudio powered by FrameworX and show you things that you may not know and some new tips and tricks. I am Tolgar Alpagut, VP of Marketing here at TATSOFT, and with me every week is Mark Taccolini, our founder and CTO. How are you today, Mark?
I'm great. Good night to everyone.
Before we begin, I just want to say that for those of you tuning in on LinkedIn, had asked if we could send this out also to YouTube. This is being broadcast on YouTube live as well. And for those of you that may miss these episodes or just want to go back above and beyond our website, our forum, and YouTube, we are also pushing this out via podcast form for anybody on Spotify or Google Podcasts. So without further ado, let's begin. Today's topic, this week we're covering intrinsically safe software. And we're gonna start out with a little bit of what exactly does that mean? And then from there, how does that relate to our product? And what are some things you should think about as it relates to that? So Mark, please.
Yeah. Well, the first time I used that expression, intrinsically safe software, I believe it was an ISA Expo. You may remember when we used to have those, that you have all the people in the same room. I was speaking to a live audience, and I used that expression of intrinsically safe software. And of course, I got the question that, what is that? Because if you Google that, you'll not find the formal definition of that. And the people kind of, oh, that does not exist, what they're talking. Well, to be fair, is in fact an analogy I'm created, bringing to the software some concepts we have in the electrical and power industry of intrinsically safe instrumentation. So a very basic definition of what's that, and sorry for the ones that really work on that area, that will not be precise on the definition. I'm talking to a broader audience. But essentially, an intrinsically safe instrument, when you talk about hardware, is that device that it may even fail. Everything eventually can put in a situation to fail, but that device, because it's for using very critical areas, when it fails, you have for sure, by design, it will not spark a fire, or the level of energy there will not compromise the entire installation. So even when you have an intrinsically safe instrumentation, it means even something happens, you'll be contained within that instrument only.
Got it.
And when you think about oil and gas platform and lots of critical pieces of infrastructure, you can make the equipment as reliable as possible, but you cannot allow that even that 0.01 whatever will blow up your facilities because of that failure. So there are many areas and many regulations on intrinsically safe instrumentation. But how that applies that concept to have a software with that concept? So I will repeat the concept. The concept is to have a software that by design is intrinsically safe. It means if you do a division by zero, a divide by zero, or there is a bad driver, or something happens, the overall application and the software will keep going. Only that specific area that had a problem will be isolated. And that's not by programming, that should be by design. The same way the hardware, the software should have that. Not say, oh, we do good testing. I'm not talking about quality procedures here. I'm talking about to create an architecture that's intrinsically safe for software. That's the concept.
So essentially what you're saying is that in the case, in a critical environment, if something were to happen, that it's contained, it's almost quarantined, right? In a way, not to be topical here, but that it
yeah, that's
right?
the expression everyone will get today.
Yeah, okay. I just want to make sure I understand.
Yeah, you to be isolated.
Yeah.
Got it. I don't know. You may have some problems on the past running Windows application, Tolgar. I don't know if you can give me some examples of problems you had.
Well, I started my journey. Yeah, I started my journey on Windows 3.1, so I've had a lot of challenges. But I would say the blue screen is a familiar one.
Yes.
That everybody's experienced.
Yeah, and the Windows crash completely. Why that happens? It happens because on Windows, all the applications, they have directly access to the operating system and even to the hardware. There is no protection. The only protection you have is make sure your code does not do anything wrong. Because the way Windows was rated, if your code wants to go to a memory from another application or the operating system itself, or do some hardware access that was not really acceptable, there is no really isolation to prevent you that. That's by design. So you can say you put quality tests, but by design, any application running in Windows, sorry to say that, is intrinsically unsafe because it can potentially harm not only the application, but the entire software application, even the entire computer where it's running. Okay, how to solve that? Okay, let's start sharing my display.
Sure.
And I know some people is sharing only through the audio, so I will try also to give enough good description on what I'm showing as much as possible. So let's see what we have here. If you just Google the words manage codes, let's start with that concept. You go to that great website called geekforgeeks.org. So that's when you Google manage code and unmanaged codes, where they have some concepts that I will start from there. Okay.
Okay.
The first basic drawing that I'm showing for you that are not looking, it's very simple. It just explain how does an application works. You have the source code of the application that can be written in any language. That source code will create an exe file. Okay. And that exe file will access the CPU, the computer, the operating system, the resources of the computer directly. Very simple diagram. On the past, we'll call that just codes with no classification. Now we call that unmanaged codes, because now we have another way to run applications in a computer that are managed. So now we have this concept of managed and unmanaged that we didn't have on the past. So what would be the diagram for a managed application? In a managed application, what does happen? You have your source codes, but your source code is compiled not yet to binary language to access the computer, but to one intermediate language. And that intermediate language will have some sort of framework or environment to run that application, to run the exe file and access the resource of the computer, not directly, because this piece here, the exe file and the access of the computer, is not your application anymore, is that framework. Mm-hmm. And for that concept to be a little more clear, I'll give two examples of runtime frameworks. One is the Microsoft .NET framework, and another one it's Java. So when you probably know that someone do an application .NET or Java, they don't say, oh, I did an application for Windows whatever version. I did this application for the .NET framework or for the Java. Why that? Doesn't matter in which operating system the .NET is running. Your application will not be allowed to access those low-level resources directly. That's the job of the framework.
Okay.
So
Mark,
go ahead.
I'm sorry, just going back to managed and unmanaged. You said they both exist, but what's the benefit at this point of using, one versus the other? Why would
let's
you not
understand that, and let's understand the difference of them. First of all, I will repeat the definition. The unmanaged code is language like C, C++, and many systems developed in the last 10, 20 years. They access directly the low-level computer resources. The managed code runs in top a platform like .NET, and is the .NET that is responsible to talk nicely with the operating system. But let's reply your good question on what that means in practical life. I'm going to show some applications in FactoryStudio where you can do even things like divide by zero with no problems. But before we go there, let's stay a little bit more on the concepts. And also from that same website, they have this, that's the website Geeks for Geeks. They have this nice simplified table explaining the difference between managed and unmanaged codes. Okay, so explain that what they call managed code was created to run inside the .NET framework. And even before I go to the table, let me ask you one thing, Tolgar. Did you ever have problem when you have a Windows update, your application stopped working?
I have fond memories of that experience, actually, because I work with a lot of audio software, and anytime there was some sort of update on Windows,
I think you are one of the 99% unlucky ones that had that one. But why that happens? That happens because those applications are accessing directly the operating system. So anything that they change can potentially break the application. When the application is running in the .NET framework, as long that computer has a .NET framework, or as long the .NET framework itself had a validation to that updates or to that version of Windows, you don't care. Because your application don't even want to know where it's really running, what version of Windows 8, Windows 10, whatever, because what they see is the .NET framework. Is that starting to make sense?
Yeah, no, absolutely it does.
So what that means when you start to drill in more technical details on that, the unmanaged code is executed directly by the operating system, whatever it is. The managed code, we have that environment, in our case, .NET, where you run. So you have one word everyone loves called hardware abstraction. If you are an HMI manufacturer or want to deploy panels in your factory or even several applications, you really love the concept to be agnostic on what hardware you are going to put there. In some cases, even from what operating system, because your applications, you break that deeply terrible connection between the specifics of your hardware and the specifics of your operating system with that abstraction layer. Okay. More, because we run on the .NET framework, we have lots of built-in security features about invasion, about authentication, about cybersecurity. I will not cover that today because that's a topic for one or two other videos. But there is lots of built-in securities, even you don't do any program in your application. That's on the unmanaged old solution, there isn't anything like that. Okay. Memory buffer overflow means nothing if you're not a programmer. So let's try to translate that for the engineers that are not programmer. Okay. In many SCADA applications, if you define an array or pack of 10 machines and try to access the machine number 11 by a mistake, in many systems that you can break completely your application.
Wow.
Or you receive data too quick that you cannot process, or you have a too long delay accessing a SQL database query. So there are many situations in the normal programming that you find yourself doing something that you have an error, and your application must prevent that and try to recover that. There is no built-in infrastructure to prevent that. In the .NET framework, that does not happen, even for a bad programmer. I say, okay, I'm a bad programmer, so I want to write this code that will invade another application code. It will not happen because it's not to the programmer to do that. It's built in the network framework, that kind of protection to isolate that areas of memory and to isolate that. Okay. Another thing that happens a lot, the application is running, okay, 1 hour, 2 hours, and then after 1 day, it stops. Or after a few hours, after a few days running well. I think working industrial automation, I believe that's something you have heard about also, Tolgar, isn't it?
Yes.
Something that runs well for a couple of minutes and then stop running.
And goes kaput. Yeah, absolutely.
Exactly. A very common error for that is because sometimes there is some sort of error that you call that exception, like I divide by 0, something that does not happen all times. Mm-hmm. But when it happens, the old style software crashes. Or also something garbage collection. And the meaning of that is exactly what it says. It's collect the garbage. When you create an application, you create some data, some temporary data that's no longer necessary. In the old style codes, you need to be aware of everything you are creating, every piece of memory you are allocating to delete that. Otherwise, that starts to build up over time.
Got it.
In the .NET framework, those features, they are built in. We don't have to worry about that. So things like memory leak or things like other typical problems that from time to time we don't have at all because, again, is in the basic infrastructure. Okay. So the only real benefits of the old style programming is when you really need what you call low-level access to the hardware.
Okay.
If you need to do things that are really very low level, playing behind the operating system doors, that's one reason to do that. But to be clear, when you talk about industrial applications, business to business, you don't need that. Because to send a message through TCP IP or to send a message through the RS-232 line, serial communication, those things, they are not low level nowadays. Those things are basic communication features that the .NET provides very safely.
Okay.
So it's really not the case to that kind of industrial application to be able to lose all the protections they have to use that. Okay.
So can you?
Good. Go ahead.
I was just going to say, can you take me through a scenario when in the unmanaged code days, when something
Sure.
did go wrong? How do you resolve it? What was the average time? I mean, what's that scenario like?
Well, let's do that. And if you have a software that's not running in .NET, if you're using things like VB script, I will ask you to try to do that in your system and see what will happen. So let's do a very simple example. Okay. Let's say I have this display here. Okay. By the way, for ones that have the video, not yet our users, that's FactoryStudio FrameworX. We have many applications here, so I just create a new one to use this example. And that's the tool used to draw displays and put some code behind the display. The code we put behind that display can be written in C#, VB.NET, or JavaScript for HTML5 pages. But going back here, this code, I'm creating a variable j, and I'm dividing this variable, my tag2, by that variable. And so essentially, you can see that in either VB.NET syntax or C#, I'm just dividing one variable by another one, but it happens that I'm doing a divide by 0 here, okay?
Mm-hmm.
And pushing back our basic math concepts, you cannot divide a number by 0. That will create one error and you crash your application. So in many systems, if I try to run this code when I'm opening this display, I will have a problem with that, okay? In our case, what does happen? Let me, hold on, go to the application, it's already running. The screen that's happening is this one here. So when I go here on this screen, you see I can navigate in between those pages. The page is still working. And I know I am having a problem because one of our debugging tools that's called trace window, it happens what shows what's happening behind the scenes, okay?
Okay.
So one thing that I will do, I'll keep that little window here so I can see that when I go to that display, I have a new message coming, showing here that we had an exception that we had divided by 0 when you attempted to enter this display by the client's application.
Wow.
So right the system is able to identify that error, but of course, in this case, going back to the codes, we have here, okay, where was that code? I think it was here. Yes. In this case, of course, the value of tag 1 is not receiving any value. We cannot evaluate that expression. So the software is not writing anything to tag 1. The only thing he's doing is he's capturing that exception and moving on, okay? That's one example on what you asked, okay? And I'll go, any questions so far, Tolgar, or I can keep going?
No, I'm actually following along here.
Good. And in fact, you can even go deeper on that. If you want just to execute something on that, you can even do a catch on that exception and do anything on that to do a code to run on that. And one benefit to use standard technologies if you have no idea what mean an exception, you can just put Google try catch, and because our language, our scripting is .NET standard, so it shows to you how you can, when you have a code that may break and you want to do a custom reply to that problem instead of the one built in the .NET, you can even customize that with that try catch. So here I'm going to do a try to do this code. And if there is any error here, like a divide by 0, I'm going to catch that error on the fly and keep running my code. For instance, I can put the value, in that case, tag 1 should receive the value of 10. And I'm going also to put a message. Say something like, let's open parentheses here, hold on. Okay. Like, you can't stop us. No divide by 0 here. Or anything you want to put. So I'm putting out this message. And so because we have online configuration, all those modifications I'm doing the display, they are already here published. So what does happen now, if I switch screens, not the login. If I keep switch in between those screens, I have now my custom message that I just created that you can't stop us, okay? So just to show that not only you have built-in protections, but you can add your own custom behavior when that critical error happens on the system.
Got it.
Okay.
Mark, can I pause?
Go ahead.
Can I pause just here for one moment? Because I missed a question that was sent here for you. It was about
please,
10
go
minutes
ahead.
ago. I'm going to try to show it on the display here. I don't know if you can see it.
Oh, yeah, I can. So let me stop sharing my display a little bit. And, okay. The question is if that concept also applies to the concept of the application running in top of FactoryStudio, if the code is isolated from the remainder of the application. Perfect question. and I'm telling you, I didn't ask him to ask me that.
No, that's a great question.
I'm glad, because this question was really perfect to give one explanation. That is why in FactoryStudio you have even one more layer of protection. Okay. So I will try to, again, explain as much as possible, but if you have the visuals, it will be a little easier because I'm going to do some little drawing here as I'm going to explain, okay? Can you see my screen, Tolgar?
Yes.
Okay. So what typically happens in the typical scenario is you have the operating system or the computer hardware itself. And as I did explain, in a typical application, you are going to create a little box here that's your application. And if it is unmanaged code, that application can play and do whatever crazy thing directly with the computer. That's the scenario, the unmanaged scenario. When you have FrameworX, what's happening? You have the computer, the operating system. Then you have as this layer that is the .NET framework. The .NET framework will be the first layer of protection to your application, okay? And then FactoryStudio itself, we are also a framework to create applications. So essentially what the FactoryStudio applications, they are created under what you call frameworks, that you can manage the frameworks as an extension of the .NET. where we put lots of built-in functionalities for industrial automation, IIoT, and real-time systems. So you don't need to do that programming on the network. If we have lots of built-in objects for you to do real-time applications more easily, that's the TATSOFT frameworks. So when you create your application here, that application or that project, okay, if you are a FactoryStudio user, you even know that project that has extension tproj, the configuration file itself. So when you do that configuration, you have the code itself being protected by the FactoryStudio framework. So that's your application running in top of that soft framework that runs in top of .NET. So, and when you understand we have those layers, you can understand why you say very confident, okay, I can guarantee this application will run properly in this Windows update or not, because we don't have the application accessing directly the lower layers. The application is accessed the TATSOFT framework. The TATSOFT framework was built in top of the .NET that access the computer hardware. Does it make sense to you, Tolgar?
Oh yeah, no, I think visually the way you've drawn this is just fantastic. And if you're listening via audio, it's, you know, the computer. It's perfect. So
frankly, I'll give a suggestion to our marketing people to redo that drawing more nicely to put on your website with that explanation.
I will take that challenge.
Because the drawing got the idea, but really is not really that great. And exploring more the concept that Daniel, he puts how we protect that. So in FactoryStudio, see, we can have many tasks, many pieces of code running. And that codes can run on the server computer or the client computer. So not only each piece of code can run in parallel if you have a computer with more than one CPU, multi-core computer, but also this code is completely isolated from this other one by the .NET framework and also by our own protection. This little trick that I did give a very basic small class of doing try-catch that I did explain that you can capture any error to put a custom message or do anything you want, okay? We do have that built-in our products. So even you don't do any of those protections, so I'm going to delete that protection on the divide by zero. So I'm not putting any custom protection. I still have this one. That's the one we put automatically to trace everything that might go wrong with your custom code application. There is no configuration, no programming for this exception message to happen in this case. Because every piece of code you create on the display, on the objects, in reaction to a button, doesn't matter. We put all those protections in place to capture and put error message and log what's happening. So you have an information. So it's not only that we recover. That .NET does for us. It's not our merit. But we do have the merit to tracking that and providing to you in an easy way so you know which protections had to be put in place. That's part of the frameworks from TATSOFT. Okay.
Thank you for that explanation, Mark. And I hope that answers your question, Daniel. And as a side note, Mark and I were talking right before the episode about giving away a TATSOFT hat to the first person to ask the question. So Daniel, congratulations. I'll reach out to you after the show and we'll get you a hat. But yeah, thank you, Mark, for that. And then if you have any questions, please do take the time to just throw them in chat and we'll definitely make sure we get them answered for you.
Exactly. And while they think about question, I do a little comment about last week we did talk about scripting, and I did talk briefly that we have things like breakpoints and things like that. So when you're switching displays, we have very advanced debugging tools that you can put the breakpoint, you can run line by line, and you can do inspection for the variables. You can do lots of things. But what I want to understand is that this concept I'm explaining today runs deeper than debugging tools. It runs deeper than quality assurance procedures. It's one thing that only can be accomplished by the architecture of the software itself. Okay.
Okay.
And I will stop sharing the video again to go another explanation, not trying to draw out. I try to draw with my hands. Everyone knows the very easy answer when you have a chain and you put some pressure to try to break, where the chain will break. In which node, which part it will break?
The weakest link.
Yes, basic concepts. In software, there is the same concepts. So if you don't literally throw away all source code you wrote 10 years ago and plus, as I did when I sold my previous company, and you don't recreate a new architecture from scratch, a .NET framework, doesn't matter if you say, oh, we support .NET. We added a .NET driver. We add this. You are adding in top of a weak link, because down deep, you have tags, you have communication drivers, you have processes that are based in that previous generations of technology. Okay.
Okay.
The only way to do, and the reason we are only one of the few products to do that, because in our case, I can say, let's forget the previous software and redo a new one from scratch without losing my job. There is no way I can lose my job gladly in this company. But I would be in a serious damage to have my risk job, that if I pick up a product selling millions of dollars and tell my boss, okay, it's time to deprecate this product and put $1 million to start a 5 years, 8 years roadmap to do a new generation, because we want to have only unmanaged code to be able to track the exceptions and avoid buffer overflows.
Yeah. I'd like to see your CFO's face.
Yeah, I can't. Yeah. So that's the reason. But I really put lots of emphasis on that, because we spent lots of time in the past, oh yeah, .NET. But say, who I care? I don't care. Well, the reason you should care is because it's amazingly less likely that an application top of .NET will stop in the factory the day you have an exception. And this name exception is a terrible name, because it's the name used in programming. But when you think in real life, that's when most of the systems have problems.
Mark, if I could just interrupt you, because you just said exception. Daniel had a follow-up question here. I'm going to show it on the screen. If you can read it out to the crowd.
Okay. The question is, when we track those exceptions, how we do with the codes. So I will share my screen again and explain exactly what happened. In the .NET programming, and in fact, not only in .NET, in programming in general, we do have, let me go to the screen I was. Okay, we do have that concept of scope. So this area here, when I select from here to here, is a piece of code. Or if I switch to VB.NET, this function here is a piece of code. So if you don't put any protection, the code that will be skipped is the function that had a problem. So this function from now on will skip the execution because you not be safe to keep doing the execution after that. If we skip one line, it will be not really possible to be safe to know if I can keep using, for instance, tag 1 after I skipped this line. You'll not be really safe to guess if the remainder of the code is safe or not. So what does happen by default, if when you have that kind of problem, the entire function is skipped. If you don't want that to happen, is when you need to define your own try-catch. So in this case, I'm doing a try-catch, and on the catch, I'm not doing anything. In this case, in fact, I'm just putting here a message. I think it will be easy. I just putting a message. Just put a message. So what does happen in this case? In this case, you are telling the application to try to do that. If you have an error, put that message, and then with or without error, keep running. So in this case, the only piece that you not run is that one line of code, because we are telling the application to run the remaining of the code with or without errors. Okay?
Got it.
Or you can even put something to run only in case of error. That's another thing you can do. Okay? So you have full access if you want to have a custom behavior. But what's very nice, even if you don't do that, we have the built-in messaging, we have the built-in logging, we have the built-in protection, even without you doing any kind of programming for that. Okay?
Okay.
And let's explore a little bit of that word exception. When you do a system and you do some sort of validation and you put in the factory to run, in the scenario you did the validation, guess what? It will work. But the problem is impossible, and there is in fact math PhD test on that, to cover 100% of the potential issues. It's called code coverage, and also when there is communication, real-time data. So it's very unfortunate, but it's very likely your critical error will happen in worst possible time. That's when you have an exception. That's not your daily activity. Is when you have combined failures of equipments, or you have a network slowdown and some meshes. So when you have those scenarios, are those protections that are even more important. So you should think about working top of managed codes, like insurance. How many times I was mad myself when I was paying insurance and driving my car very nicely and slowly and has a full year with 0 incidents and paying huge amounts of all kind of insurance. But we do pay. In some cases, even for law that you need to pay. That's the same for that. All those protection, all those safety, it helps you to avoid problems and helps you to find a problem 10 times, 20 times quicker if you have. Okay. Great. First, but I'm not going to have problems. I will write code carefully. Okay. In that case, just to wrap up this session, I recommend to see the other videos we are doing, because even it's not because the exceptions, the .NET has very interesting features like autofill the name of the tags, object model, so you know all the properties right away. I'll not go on the demo on that, so just remind. We have lots of features that the programming in .NET is quicker, is faster than the programming in the other one. Yeah. I would say it's from 10 times to 20 times faster.
Wow.
And I have that experience because I developed on the past a software that was more simple than FrameworX, my previous generation products. And it took 10 times less time to create frameworks than we put on that other system. Yeah, so it's a
Yeah.
great difference. And I can tell by personal experience, have me exposed to both technologies. That's it.
That's incredible. Yeah, no, I hope that answers your question, Daniel. And I found this very informative, and I think it's so. Let me just ask you this. This is more kind of around the messaging, but how did you come across taking intrinsically safe and adopting it for the software as your kind of term? Because I haven't really heard that, right?
Well,
it
it was exactly because I was about to do a presentation on software security. The reason, the main topic was cybersecurity, but I was trying to explain that you put lots of security on the upper levels, but you are doing that in top something that you can hack easily.
Yeah.
It does not really work very well. So you need to go on the foundation. And every time that I was explaining .NET, managed code, runtime environments, just-in-time compiler, I see my audience going, oh, the eyes rolling, or worst case scenario, leaving.
Yeah, you just losing them at that point.
And work with industrial automation, I really try to find an example to relate to something more physical. Because one problem that we do have as a software technology company is we have amazing great infrastructure, amazing great technology. So most of the people don't see that because it's not visible. Sometimes they see a demo for a system that's way more simple than us, but they have a nice artist that needs a beautiful 3D drawing. That behind that there is nothing, but what you can see is what you can understand. And we do have, frankly, the best and safe technology on the market for real-time industrial automations, but it's too hidden. You cannot see those things. So that's when, for that presentation, I come up with the idea, okay, let's pick up something that's very physical. They can understand. An industrial automation engineer in oil and gas and other areas, they understand very well why they pay an extra price to have intrinsically safe equipment.
Yeah.
In our case, not even charge the extra price, but we try to make those automation engineers understand that intrinsically safe concept, the same way it's important for your instrumentation to not blow up your critical system, we do have that. And this value is built in on the system. Even gladly you don't see that. That's perfect. I don't think anyone that has insurance wants to use the insurance all times.
Yeah, absolutely.
You don't need to see that. It's okay. You just need to understand it's there and perceive the value for that.
No, I mean, as a marketing guy, I think that's great how you took that, complex concept that's maybe not as tangible, you can't feel it, and put it in a context. All right. Okay. Well, I appreciate today's episode and, all the information that you provided. Is there anything else you want to talk about?
No, just hoping everyone, especially in my Texas states, back into a reasonably normal life.
Yeah, no, definitely. And I did hear it's getting a little warmer, so that's good. At least there's some positives happening. Just two quick things really before we go. March 25th, if you haven't seen their post, save the date. We've got some stuff happening, so we'll be making an announcement next week. And then again, if you have any questions following this episode, you can always throw them on forum.tatsoft.com. And Mark, do you have any topic in mind yet that you want to talk about, or are we going to push out the survey and ask, what would you like to do?
Well, instead of pick up in one, let's see if you got some email, some requests, and we can let people know that tomorrow.
All right, perfect. Let's do that then. All right, again, thank you very much for your time, Mark, and the explanation, and thanks for everyone for tuning in. Daniel, I'll be in touch in regards to your hat, and thanks for your questions. So until next time, have a good one, everyone. See you next Thursday.